All right, folks. Well, welcome back. Apologize about yesterday. We had issues that really made it difficult to get this lecture out to you. But hopefully, we'll try to get caught up with today. Okay, so let's quickly. So hopefully everyone had a good weekend, and so it's been quite a bit of time that's lapsed since we last met on Thursday. So I want to go ahead and I want to just quickly review what we did up until this point. Okay, so we were talking about how we can describe motion. Okay, we can describe motion in a number of different ways. We can describe it using words. But remember, in physics here, what we're going to try to do is we're going to try to describe motion in terms of numbers and in more of a quantitative way. And one of the easiest ways to identify motion is to see how an object's position changes over time. And we know then that an object moves if the object changes its position. If it starts out somewhere and then ends up somewhere else. Okay, so we can describe the position change over time. We can also graph that positional change over time as well. And a graph of the positional change over time allows us then, and graphs are great tools to use, and when we'll have to learn how to not only make the graphs, but interpret the graphs as well. Hopefully when we get back and we meet again, we'll be able to do this here. But a graph of motion makes it very easy to see patterns that emerge in that particular motion. And from those patterns, we can then simplify it a little bit more, take the information on the graph, and come up with an equation to describe that particular phenomenon. Okay, and so that's the idea behind physics, and that's what makes physics so unique, is that we can not only make observations, but we can use our observations to make predictions about what will happen later on at some other moment in time or at some other position. And so that's what we're going to work towards once we finish this here. Okay, so what we did on Thursday then was we were able to take a position time graph, and in a position time graph then, what we have then is the position of an object as it relates to the time. And so if you take a look at here on a position time graph, we have position plotted along the y-axis, time plotted along the x-axis, and at any moment in time, we can indicate the position based upon our particular graph. Okay? So each point on the graph, each point on this curve here, for example, represents the position of an object at a given moment in time. So what we did was basically we recorded the motion and the position of an object as it moves. Okay? All right. So we were able to interpret this position time graph. We were able to see then from this position time graph that this object is actually moving along a straight line path. And so what we did is we took each one of the points here. We took A, B, C, D, E, and F. And we designate the time and its position at that given time. So for example, at position A, or at point A, we know that that's where the object started out at. And the object started out at a position that was 30 meters away from a reference point that we call 0. Now make sure you understand then, in order for us to describe the motion of an object, we have to agree upon a set of positions. Okay? And we have to agree upon how we're going to measure those positional points on in the object's motion. And in order to do so, we always have to indicate then a point in the motion where the object is at what we call 0. Okay, from there then we can go ahead and indicate the change or the object's position relative to that 0 point. The 0 point can be an arbitrary point, folks. It can be any point that you want to choose, but we do have to designate a 0 point. Okay, so with that said then, what we're indicating here then is that on this particular graph, on this particular position time graph, the object then starts out at a position that is 30 meters away from where we indicated it as 0. Okay, so this position here, what we're designating point A, that's when we start our time. So the object then is 30 meters away from us. So let's imagine that we designate ourselves at 0, okay, and then we have another object, another person here. So when we start the timing that person's motion, the person starts 30 meters down from us. So let's say we're on a football field. Let's imagine we're out here on the football field. We are standing at the goal at the 50-yard line. We indicate that as 0. The person that we're measuring, we are tracking, is going to be 30 meters away from us. 30 meters away from us. So that's what we have indicated here. So there we are. Let's say that this is our football field, and remember, The motion that we are indicating at this point here is just one-dimensional motion, an object that's moving along either an x-axis or a y-axis or a z-axis or any axis, but it's only moving along one dimension. Okay, so the object basically move forward and back, left and right, east or west, north or south. So it's only a one-dimensional motion. Okay, so moving along a straight line. So let's imagine this here. The person that we're tracking we're standing at the 50-yard line right here. The person we're tracking is 30 meters away from us, 30 meters away from us here, and that's at position time 0. Okay, that's his or her position at time 0. Then what we start noticing is that person starts to move away from us. Okay, by the time he gets to 10 seconds after we start the clock, he has moved then to a position that is at 50. We said roughly 50 meters away from us. Okay, so if you notice that he has moved, if you're tracking this, or he's moving away from us, the new position, that change in position, and that change in position from time 10 seconds to time time 0 seconds is 20 meters. So he's moved 20 meters away from us, and that's what we have designated here. So what we've done then, we're taking this particular curve here and we are highlighting how the object moves in a straight line. Okay? All right, so once the object gets to position B, we talked about how the object now turns around and comes back. Why? Because if you look at this line now, this curve here is starting to move back towards 0. The position is moving back towards 0. So what that indicates then is that the person then is turning around at time that 10 seconds, he turns around and he starts moving back towards 0. He starts to move back towards us, so that by the time we get to 20 seconds, he is at a position that is roughly about 38 meters away from us, 38 meters away from 0. So we are indicating then that we are at position 0. He's moving back towards 0. He's moving back towards us. Okay? So that by the time he gets to point D, here, which is 30 seconds from the time he started, he is now back with us right here. He is at point 0. So you can imagine then on the football field, we are standing on the 50-yard line with that particular person. So he's moving back towards us at point D. Okay? And so what I asked you to do then is describe what happens to point E and point F. Okay? And so let's go ahead and take a look at that. Okay, so let's go ahead, let's take a look at what happens at point E and point F. And hopefully I think you got this down okay. Okay. All right, so let me clear this up here. And so this is what we have here. So let's take a look at what happens at point E first. Okay. So at point E then, let's say then, now at point E, he's moved, the total time now is 40 seconds. And from the graph then, he continues to move away from us, not in the original direction. Okay, so he's coming back and he continues to move in the negative direction. Okay, so if you can imagine that he moves in this direction here. Okay. He continues to move, he gets to us, then he continues to move away from us, and he ends up at a position at times equal now to 40 seconds, at a position that is on the opposite side of where he started. So he's not on the same side where he started. He's on the opposite side of the field now. And so we have to designate then that since he's not at a position that is 38 meters on the right side of us, we have to designate that with the negative sign. So he ends up here at the end of 40 seconds, 38, sorry. He ends up at a position that is 38 meters away from us, but in the opposite direction. And that's what the negative sign indicates right there. Okay, so this is going to be then motions at point E. So this is the motion represented by point E. At the end of the 40 seconds, and this is total time now, folks, so it doesn't take him 40 seconds to move here. This is 40 seconds from the time we started recording his motion. At time equals to 0 here, he moves and then he comes back around, and then at the end of 40 seconds, the total 40 seconds, he ends up at a position 38 meters to the left of us. Okay. All right, so that's going to be point E there. So point F then, and if you take a look at this point F, he continues to move in the negative direction because he ends up from here, he ends up 10 meters down the line, okay, at a time of T is equal to 50 seconds. Okay. And so he ends up then at point F here, the motion represented by F, he ends up at a position then right here. That is finally 50 meters away from us, but in the opposite direction where he started out at. And so that is how we can take the information here, folks. So let's go ahead and take a look at this. Okay, so hopefully you have that. That is how we can take the information that is given to us on this graph here and interpret it as an object moving in a straight line. Okay, so even though the graph itself is not a straight line, the motion represented by this particular position time graph is a straight line motion. And so you have to be able to take this information here that's given to us on the position time graph and then try to visualize how the object is moving, but moving along a straight line. Okay, and so we have to be able to interpret. So let's go ahead. Let's practice this here, and I'm going to go ahead and work this one out with you. Okay, so let's go ahead, and we saw this picture earlier, and let's plot the motion of the truck here. Plot the motion of the truck here as it moves from its initial position to its final position here. Okay, so again, along the y-x-axis, we're going to designate time, the time along the x-axis, and position along the y-axis. We will measure position in units of meters, and we will measure time in units of seconds. All right, so position time. We're going to designate then this point here as being 0, okay? And if we want to, we can call where the catcher is at point 0, okay? So this is our graph, okay? This is our graph, and here is our straight line motion, okay? So let's draw out the straight line, and I'll draw it right here for us, okay? So here's our straight line, okay? All right, so let's say then that this is right here 0 meters, and we'll say that the catcher is at 0 meters. The catcher is at 0 meters. So this is going to be times equal to 0. We'll call that the initial time there, times equal to 0 seconds. Let's say then that this is, let's say 10 seconds later. Okay, so time, this is T naught, this is T1, and this will be T2. T2 then we'll say then is 20 seconds. 20 seconds away from 20 seconds after we started the clock. Okay. All right, so let me ask you this, and just make sure you answer this question in your head, okay, on your own. Okay, does the truck start where the catch is? Does this truck start at 0 meters? Does the truck start at 0 meters? The answer is no. The truck, when at time 0, is a certain distance away from the catcher, and again, the catcher then is designated 0. So we will say then that the truck starts out here, and we'll just say arbitrarily he starts at a distance of 10 meters. I'm sorry, 40, let's say 20 meters away from the catcher. And that's going to be a T equals 0 seconds. Okay, so let's designate each one of these here as 5 meters. Okay, so we have 5, 10, 15, 20. So each tick mark here is 5 meters. So it's 5, 10. So this will be at 10 meters, 15, 20. And so make sure when you do this that you are consistent with your labeling. Okay. Again, how you label this will be arbitrary, but you got to be consistent with your labeling. Okay. So let's call each one of these 2 seconds each. So it'll be 2, 4, 6, 8, 10 seconds here. Okay. 2, 4, 6, 8, 10. There'll be 20 seconds here. So along the x-axis, time, each tick mark represents a 2-second time interval. Along the x-axis, each tick mark represents a 5-meter interval. Okay. All right. So let's go ahead. So now that we have that label, let's indicate the motion here. Okay. So the truck then starts out at a position then that is 20 meters away. So let's go ahead then that x initial here is going to be 20 meters. Okay, so we'll say then the truck starts out right there. Okay, so this truck starts out right there. And so let's go ahead and do this here. Let me ask you this, does the truck start moving away from the catcher, or does it move toward the catcher? Okay, so if you take a look at this here, the truck then moves towards the catcher, and that means it moves towards 0. So let's go ahead and let's put this here, and let's say then he moves to a distance that is about 5 meters away. So x1 is going to be 5 meters away, okay? And he's going to be moving in a direction here, okay, that is 5 meters away. So he starts out at 20, and he ends up at 5. So let's go ahead and let's plot that at 10 seconds here. He ends up at 5. And so the line then is designated right there. Okay. So he starts out at 20, he ends up at 5. So during this 10-second time interval, he moves back towards the origin. Okay, so the line then is going to be down. And then at this point then, what does he do? He stops. Okay, and then let's say here at x is equal to at x when x is 20 at 20 seconds, he ends up at a distance that is, let's say, 30 meters away. Okay, so understand this, the position here is still on the positive side of things. So this is still a positive, though when we calculate for this in just a moment, we're going to see that the displacement is negative, but he ends up at a position that is still on the positive side. So remember, the negative side of position would be below the x-axis, but he still ends up on the positive side of the position. Okay? Then he moves a distance at 20 seconds that is 30 meters away. So let's go ahead and plot this here. So at 20 seconds here, he ends up at a position that is 30. Okay, and so then he turns around and he goes back up, and he goes to a position that's 30 meters away. That is the plot for the motion of this truck. Okay, so he moves back, and then he moves back towards the origin, then he moves away from the origin. Okay, all right, so that's what we have right there. So this plot here, this very simple plot, plots then the motion of this truck. Okay, all right, very good. So what I would like you to do then, real quick for me, calculate for the displacement, the total displacement for the truck from position initial to position 1. Okay, so what is the change? So I'm sorry, let me go ahead and do this for you. So that's going to be then x, remember, change of position is going to be x final, which is x1 here, minus x initial. Okay, so that's how we calculate for the position. So the displacement from 0 seconds to 10 seconds, I'm sorry, from 0 to 10 seconds. Okay? All right, so he starts out at the position final. Sorry, okay? He ends up at a position that is 5 meters away from the origin, but he starts out at a position that is 20 meters away. Okay, and so therefore his displacement then is going to be negative. Okay, and it's going to be negative 15 meters. So he moved a total distance of 15 meters, but in the negative direction. So that is his displacement right there. Okay. All right, what I would like you to do, so pause the video once I get this done for you. What I'd like you to do is calculate for his displacement from position 10 seconds to the position at 20 seconds. Okay, so you're going to solve for then x, I'm sorry, this is x equals to 10, 0, 10 seconds. Okay, 10 seconds. Okay, so x at 20 seconds minus x at 10 seconds. Okay, so, all right, so I'm going to pause the video here. Make sure on your paper, solve for the displacement here for for this particular truck as it moves from 10 seconds to 20 seconds for that final time interval. Okay, so take about a minute to calculate for this, and then when we get back, I'll do the work for you. Okay, so on your paper, show me what the displacement is from 10 seconds to 20 seconds. Okay? All right, let's go ahead and let's take a look at this then. So the position at 20 seconds is 20 meters away from the origin, and the position at 10 seconds is 5 meters away from the origin. So therefore the displacement then here is going to be positive 15 meters, okay, because he moves in the positive direction. So let's make sure we interpret this and understand what this exactly is telling us. Okay, so understand, even though the displacement here is negative, the truck ends up at a position that is a positive 5 meters because he's still on the positive side of this positional graph here. Okay, but he moves back towards the origin. Then here we have a positive 15 meters because now he turns and he moves in the positive direction. Okay, so the direction here, even though the total distance traveled is the same, the direction then is going to be completely different. Okay, I'm sorry, he ended up at 30 meters. Sorry, 30 meters, sorry. So this is gonna be 25. I apologize for that. So this would be, yeah, the line doesn't look the same. So even as I record the video, I still have old age to deal with. So I apologize for that, folks. So he moved the total distance of a positive 25 meters. So he goes from 5 meters to 30 meters. And so this is positive because he moves in the positive direction. The slope here and thus the direction here is going to be very important when we talk about the speed and velocity in just a moment. Okay, so please make sure then that you can that you remember how to do this. Okay, and then we'll move forward with this. Okay. All right. Hopefully you got that. Let's move forward then, folks. And let me erase this here. Okay. Sorry. Okay. All right, so what I'd like to do is I'm going to pause here. We're going to finish up with this problem here. Take about a couple minutes to answer some questions about this here, answer this question here, and then we'll talk about it when you get back. Okay, so take about a couple minutes to answer this question. Okay. Okay. Well, let's take a look at this here. The question's asking us this. The question's asking us then about which one of these motions is possible. So we have position time graph on each one of these here. So position time graph on each one of these. Let's interpret what this first one means here. This first one then is telling us that an object here starts at some position away from the origin, okay? And he starts to move away from the origin, turns around, comes back towards the origin a little bit. So he turns around and comes back, and then he turns again and goes back and moves in his original direction, okay? So if we were to draw out this line here, represent this motion here along a straight line. Okay, so this is going to be the origin here at 0 meters. Okay, the object then starts to move away from the origin. Okay, then turns around, comes back towards the origin, and then moves away, back away again, and continues on in the opposite direction. Okay. All right, so this one is absolutely possible. That's possible because then you see then the object is moving away at time. And so this, you can imagine this is time is equal to 0 seconds. Okay. And here, time is equal time 1, let's say 5 seconds later. Okay. And then here he moves back 10 seconds and then so forth. Okay. So this motion is completely possible. Okay. Let's take a look at, let's interpret what happens in graph C. Okay, so again, the object moves away from the origin. So let's go ahead and consider this the origin, 0 meters. Okay, and he starts out then at a position that is away from the origin. So this is his time is equal to 0. Okay, so he moves away from his initial position. So this is x equals initial. He moves away. And then at some point here, he turns around and he comes back, never quite getting back towards his initial position. Okay? And I'm sorry, and then he continues to move back here. He starts to move back and then at time, and before he gets back to the initial position, he stops right here. Okay, so he doesn't quite get back to his initial position. Okay, so that seems to work as well. Okay. All right, so A and C do represent actual motion. Okay, let's take a look at what's wrong with B. Okay, let's take a look at what's wrong with B. So here the object starts out again, moves away from the origin, moves away from his initial position. Okay, and then looks like here he turns around and he goes back. That's what it looks like on this curve here. But let's be careful about what actually is happening here. So let me pinpoint indicate 2 points here on the graph. Okay. Okay. And let's understand what this means here. Okay, so this is a single time. Okay. Let's look at what interpret this meaning here. Okay. Okay. So we'll call this let's call this point 2 and this point 1. Okay. And so what do you notice at these 2 points here? Both points have the same time. Time is the same for each one of these, and yet the position then, we'll call this x2, y2, and y1. If you notice here, each one of these, the coordinates here is going to be t1, t, and y2. This is going to be t and y1. They both have the same x coordinate. So if we were to interpret that in terms of what we know, what is that saying? It's saying then that this object at a moment in time is at two different positions. Okay, so this same object at the same time can be in two different positions, and that, folks, is not physically possible. Okay, so that's why this graph cannot be correct, because it's showing then an object that is in two different positions at the same time. The other way that people have interpreted this also is that this object then goes back in time. It goes back in time, starts out at a given position, then he goes back in time and changes his position as well, and that we also know cannot be the case. So the reason why then the graph B cannot be possible is for two reasons. You can't have an object being in two positions at the same time. And secondly, you cannot have an object go back in time. Okay? And so hopefully with that said then, folks, you learn to interpret these position time graphs and obtain information based upon the position time graph. Okay? And so what we're going to do tomorrow then is we're going to, and I'll just put this up for you, we will go ahead and we will use this information, and we're going to practice this a little bit more. And then what we'll do then is we're going to take this information and talk about velocity time graph. Okay. All right. Very good, folks. That's it for today. So make sure you post the work, the one thing that I asked you to do with the displacement. Okay. And then post that for the assignment for this lecture. Okay. All right, so folks, come by after school today, 3:15 to 4:15, if you have any questions, and then come by and or I will see you tomorrow. Okay. All right. Very good.